So factoring your trinomial involves setting up your question with two brackets, and you will try to come up with two terms that will give us a product of this. And then we will need two terms that will give us a product of that. So for this example, 2k to the 4, what are the two terms that will give us a product of 2k to the 4? 2k squared, I heard 2k squared, and k squared. These two will multiply to give us 2k to the 4. What about the one at the back? What are the two numbers here and there? 1 and 1, yes. And now seeing how it is -1, the product of these two numbers will give us -1, or in another word, one of these numbers will come with a negative. We need a negative and a positive for the ones here. So would it be this way, or would it be that way? It all depends on the inside and the outside. So we are going to make use of the inside and outside. This gives us 1k squared, and those two will give us 2k squared. How do I come up with minus k squared using this and that? Would it be 2k squared minus 1k squared, or would it be 1k squared minus 2k squared? Yep, 1k squared minus 2k squared. And if this will give us a plus, the plus goes here, and the minus goes there. Here is the tricky part about factoring expressions like this. Once you think you're done with this trinomial, make sure you check it out and actually make sure you have this completed. When you look at the result here, we can do something extra on this. K squared minus 1. This will give us a difference of square, which means we need to factor this further. The k squared minus 1 will turn into k minus 1 and k plus 1. So we want to get it done as well.
Is that only when it's a negative?
Only when it comes with a minus between perfect square and perfect square. Difference of square, this is what we call them. There are also times when they give us an expressions that carry a GCF at the beginning. When you look at the next example here, we have 147, we have 3 in these two terms. Both of them are divisible by 3. I can take it out as a GCF. But besides the 3, what else are in common? Y squared and Z squared. Make sure you take out all the GCF before you start your factoring. Once I take out the GCF, can we work on this again? Is it a difference of square? Yeah, 49 is a perfect square, y squared is a perfect square, z squared is a perfect square. We can factor this binomial into 7y minus z, and 7y plus z. So this is where we will stop.